Look at the IC map again. Remember, a consumer wants to go to the highest IC possible, but we know they can't, right? If every consumer wants to go to the highest IC, what is it that stops them? It is their budget, like a brick wall preventing happy things. Crusoe has come to a supermarket now, and after that island, it feels like heaven now. So many choices, he feels like buying a lot. He feels like buying everything around. But scarcity will always come back, right? And what is scarce for him now? Money. Reality hits him, budget hits him. If the prices of the goods are fixed and Crusoe's income is also fixed, he can afford to buy only those bundles which cost less than or equal to his income. That is his budget. Let us denote his income by M, and let us denote price of milk and eggs by P milk and P egg. Then we can say P milk into quantity of milk plus P egg into quantity of eggs should be less than or equal to the budget constraint, that is M. This equation you see here is the equation for the budget constraint. We can also represent all this with generic algebraic terms, right? To write the generic equation for the line, we can just use P1 and X1 for milk and P2 and X2 for eggs. Then it becomes P1x1 plus P2x2 is less than or equal to M. And all the bundles that meet this criteria, we can call the budget set. Once we have an equation like this, we can also represent it graphically. Then it becomes the budget line, which is P1x1 plus P2x2 is equal to M. The budget line consists of all bundles which cost exactly equal to M. All points below the budget line represents bundles which cost strictly less than M. Now, if all of Crusoe's money was spent on just one good, we get point A here on this axis. If all his money was spent on the other good, then point B on this axis. If we join these 2 points together, we get the same budget line again. Now, these 2 points are intercepts again, remember? If we rearrange our earlier equation, we can get x2 is equal to m by p2 minus p1 by p2 x1. Then the horizontal intercept is m by p1 and the vertical intercept is m by p2. The horizontal intercept represents the bundle that the consumer can buy if he spends his entire income on good 1. And similarly, the vertical intercept for good 2. Let us now take a point on the budget line. At this point, Crusoe has filled his cart with some combo of milk and eggs and his money is over. But what if he now wants one more milk bottle? He can only do this by substituting. He will have to give up some eggs to get some milk. How much of eggs will Crusoe have to give up if he wants to have one more unit of milk? For this, he has to move along his budget line now. And this depends on the prices of the 2 goods. A unit of milk costs P1. Where will he get this extra P1 amount from? He will have to reduce his expenditure on eggs by P1 to get that extra unit of milk. With that, the amount P1 is freed up to buy milk. But how many eggs did he have to give up? With that P1, how many eggs could he have bought? Since eggs cost P2, he could buy P1 by P2 units of eggs with P1. That is how many eggs he had to give up. Let us take some real numbers to explain this. Let us say milk costs 10 rupees and let's say eggs cost 5 rupees. And Crusoe wants to have one more milk bottle. How much money does he need? He needs 10 rupees, right? To get the 10 rupees, he has to give up some eggs. How many eggs does he have to give up to get 10 rupees? He has to give up 10 by 5 or 2 eggs. So here P1 by P2 becomes 2 and that is the amount of eggs he had to give up. So that is what we were discussing earlier with P1 by P2, etc. Therefore, if Crusoe wants to have an extra bottle of milk when he's spending all his money, that is when already on the budget line, he will have to give up P1 by P2 units of eggs to achieve that. In other words, in the given market conditions of given income and prices, the consumer, that is Crusoe, can substitute good 1 milk for good 2 eggs at the rate P1 by P2. And this is the slope of the budget line, the ratio P1 by P2. The slope is negative, of course. It is the ratio at which consumer can substitute one good for another along the budget line. That is, making sure his full budget is spent. One funny thing here is, in economics, we assume it is very important for people to spend their entire budget. No money left is equal to happy Crusoe. Remember this, we'll be using this a bit later. Isn't the budget line similar to the PPF in how it operates? That is why sometimes the budget line is also called as CPF, Consumption Possibilities Frontier. What about points above the budget line? No way, right? Crusoe doesn't have that much money. And what about points below the budget line? Such a point represents a bundle which costs less than Crusoe's income or budget. But remember, Crusoe is very keen on spending all his money. This is because if the consumer buys such a bundle, he will have some money left over. And in principle, Crusoe could spend this extra money on either of the two goods and thus buy a bundle which consists of more of at least one of the goods compared to the bundle chosen by him first. In other words, compared to a point below the budget line, there is always some bundle on the budget line which contains more of at least one of the goods and no less of the other. And money not spent is satisfaction not purchased. To make it easier, assume it is the last day on earth for Crusoe. Now does it make sense? The money has to be spent to get utility. Otherwise it will be wasted, right? Try thinking when you would feel the same way about money. So in our example, we make that assumption. So it's basically about trading money for satisfaction. Money by itself can't give satisfaction. So no point saving it, right? Spend and enjoy life. So finally, understand this. Crusoe wants to spend all his money, okay? He doesn't want to be at any point below the budget line, strictly.
Can the budget line change?
Yes, of course. Basically, we're asking if this will always be the budget line. Can the ball be moved, right? Answer is, yeah, it can be. We learned budget line depends on two things, income and price of the goods. So if anything changes, either income changes or prices change, then the budget line will move. Let us think of two such scenarios. First, let us see what happens if Crusoe gets a higher income. Now he can buy more goods at the same prices. So both the intercepts on the graph will change. This is the new budget line for Crusoe. Second, what if price of a good changes? Government announces a subsidy on milk. So price of milk comes down. Now intercept on that axis changes, correct? This means he can buy more of it. Note that the slope of the budget line has changed now, whereas in the first case it had not. Why? Because the ratio of prices has changed. One has become cheaper. Crusoe can buy more of the same budget or money he had earlier. Now, an exercise for you. Try to plot out for yourself how the budget line will change in the opposite circumstances. If income comes down or if prices of a good goes up. Draw it out with pen and paper and see. Another exercise also for you. Imagine how you would behave if movie tickets became really cheap. Would you spend more on movies or would you spend less? Think about it with graphs. Okay, so seems like Crusoe has spent a lot of time in the supermarket now. Let us help him decide and get out. We have understood two graphs till now, right? One, the ICs and the IC map, and the budget line graph. Now let us merge those two curves. This was the wall we saw earlier. It separates the bundles available to Crusoe from the ones unavailable to him. And Crusoe wants to be on the highest possible indifference curve. But he can't cross the budget line. So obviously, the optimum point, the optimum choice, or the optimum bundle has to be located on the budget line. A point below the budget line cannot be the optimum. A point above is not possible, right? Plus, the optimum bundle has to be on the highest possible IC touching the budget line. That is, the budget line would be a tangent to it. Why? Why is that so? Because Crusoe would want to be on the highest possible IC always. He gets max total utility or TU on that line. Consider the curve now. Crusoe would want to be on IC3, which is the highest possible IC because the budget line is tangent to it. Crusoe will choose point B on this graph. What about these 2 points here? He can't choose point E, even though he would be happier there. And he won't choose D because he would get less satisfaction there.
But what about the points A and C? They are also on the budget line.
Good question. Why not A and C? Remember monotonicity of preferences? A and C are points on a lower IC. Simple as that. They give him only the same amount of satisfaction as D, and B is above D. So obviously, the TU of B is higher than A and C. Coming back to our discussion, let us see what happens if we move along the IC2. The TU on this line is only say 10 at A, D and C. But when we go to B, it becomes 15. So it becomes a higher indifference curve. At this point B, right, two ideas we saw earlier comes together. First, we studied indifference curves and their slopes. Then we studied budget line and its slope. At this point, you will notice the slope of the indifference curve becomes equal to the slope of the budget line. Here we can say the MRS or the marginal rate of substitution becomes equal to the ratio of prices. And that's it. At this point, Crusoe finally has his optimal bundle. He can now buy and leave. Finally. Let's have a quick look at all the concepts we have covered in this chapter. We've ticked off quite a few concepts here, right? A lot of things we have studied in this chapter. But there is one more crucial idea I want to introduce you to before we close this chapter. That idea is called demand. We will not cover it in full detail here. We'll only do an introduction in this chapter. The rest will be covered in the next chapter.